That's one of the benefits of Wi-Fi. Not only is it pervasive and it's everywhere, but I think one of the key points about Wi-Fi that makes it so ubiquitous is the fact that it's backward compatible.
Hey, this is Martha DeGrasse here again for Wi-Fi Alliance, and this is The Signal, our podcast where we give you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. In this episode, we're going to be learning about Wi-Fi 7 for network operators and service providers with James Kimery. He is VP of Product Management at Spirent Communications. James, welcome to The Signal.
Thank you, Martha. I appreciate it.
Yeah, well, we have a lot to start with today, and I think that at the beginning, though, there might be some people that don't exactly know what Spirent does, so if you could give us a quick overview of the company and your role there, that would be great.
Okay, well, Spirent actually began as a company in 1936 in the UK, so it's been in business for quite a while, but we focus on test and measurement solutions, mainly for the communications industry, cellular, Wi-Fi. We also do a lot of network testing, along with our communications portfolio. I'm actually in a BU, business unit, called Automated Test and Assurance. So not only do we have test and measurement solutions, but we also have service assurance solutions as well. Then my role within Spirent is I'm in charge of all of our wireless portfolio in the ATA, Automated Test and Assurance business unit.
So that's going to include Wi-Fi and cellular, is that right?
It does.
Okay, great. Well, we are going to focus on Wi-Fi 7 today. So let's start by learning if there are any specific test challenges for Wi-Fi 7.
Yes, there are quite a few test challenges. So first, one of the benefits of Wi-Fi 7, there's a lot of technical features. I'll just go through them. And then what does that ultimately impact the end user? So the first is 320 megahertz of bandwidth. You know, this double the bandwidth of Wi-Fi 6, potentially double the throughput. And then you combine that with this 4K QAM, which basically gives more bits per spectrum. So it's about another 20% increase from 10 bits in Wi-Fi 6 to 12 bits in Wi-Fi 7, roughly a 20% increase in throughput. And then really excitingly, I think, is this new technology called multi-link operation, or MLO. So those three features, there's more features to Wi-Fi 7, but those three features in particular, there's a throughput or data throughput component. And from an end user perspective, the amount of data that can be transmitted or received between a Wi-Fi link and Wi-Fi 7 increases exponentially. And so, I don't want to give specific numbers in terms of throughput because everybody's wireless environment is different, but the features that are there are certainly, it's a big step up in terms of data throughput and probably end user experience as well. In terms of test challenges, that means that the test equipment, really if you're testing throughput with the device, it's a redesign of the infrastructure of the test and measurement equipment, because now we have just wildly increase in throughput that we have to measure. A couple other things related to that: twice the bandwidth means that the equipment has to have twice the bandwidth, but also the 4K QAM is really interesting because if you think about you're throwing a ball through a hole in the wall. With Wi-Fi 6, that hole is maybe as big as a house, and now you have to go through a much smaller window. And that's what 4096 or 4K QAM means. It means that the data throughput has to be precise. One of the key pieces of that is phase noise. And so the phase noise of the equipment has to be so much better than what it's testing to be able to resolve that many bits in a particular amount of spectrum. And then multi-link operation means that now I've got potentially 3 different radios operating at the same time, and I have to aggregate all of that bandwidth. 2.4, 5 gigahertz, 6 and 6E spectrum can operate simultaneously, both in transmit and receive. So it's a big jump in terms of throughput, but each one of those features that contribute to that big throughput, it does have a big impact not only on the end user devices, AP router, but also on the test equipment itself.
This test equipment, do you usually take it to locations for your service provider customers? Do they bring equipment to you? Is it some of both? And I know you do offer test as a service, so they can just send it to you and you test it and send it back sometimes, right?
We can. One of the things that we do at Spirent with our Wi-Fi testing is we deliver a test bed, and we have chambers that isolate the different components. So if you're testing a cell phone, if you're testing an access point, those devices are completely isolated from each other. And then we connect the chambers with a device, not only cables, of course, cables that go to antennas, but it's an attenuation box. And what that enables us to do is in the lab, we can recreate any environment, 2-story house, 3-story house, apartment, urban, whatever. We can take basically a snapshot of any of those structures that I mentioned, and we basically record it. And then when you put your device in there, it looks like, oh, it's a 3-story building, or it's a system that has multiple access points and multiple interferers. That's what we do. And what's nice about that is that some vendors do test their devices in specific structures. That's a common practice. We don't actually have to do that. And that's one of the benefits of the spirent system, is you can rely on our library of different structures that we have recorded. And then guess what? Those devices can be tested repeatedly. I mean, that's key point in test is you do it one time and you get a good result. That's okay. But, as you improve the software, hardware, packaging, antennas, you want to repeat those tests and you want to see, hey, how did that new thing that I added, hardware, software, whatever, did that improve performance? Did that break something? Where's my baseline and how did it hopefully improve? So that's what we do. We can recreate that with our Octabox platform.
Very nice. And do you ever do bake-offs for the internet service providers, like if they have different Wi-Fi routers and they want to see which one's the best?
We do. So, it's one of the benefits of working with a wide group of customers is that, our test beds, they are quite comprehensive. Over the years, we've been doing Wi-Fi testing for close to 20 years now. And we have a big repository of tests that we can run. And so we've offered test as a service I think we started it about 2 years ago. And so operators can send devices, we can test them. We usually, during an engagement, will go through a series of tests and we'll negotiate what tests that they would like to run. And typically what the internet service providers really want to see is this access point give me better throughput than this one, or for these in the apartment case or the 3-story building case, which one actually performs optimally. And so we provide that test as a service, and then those results are obviously secure and only provided to that particular customer. But that's been a very popular service that we offer.
I bet a lot of people would like to know more about those results if they could. Okay, what about mesh? We hear a lot about mesh networking on this podcast. Does that change the test process at all, having to figure out how mesh is going to work?
Yes, mesh is independent of the Wi-Fi standards. Basically, it's a system that has multiple access points, and the access points can communicate, but really the access points point the beams to the users, and either they're moving or they're static, but they move the beams in order to enable the best performance and coverage. And there's no standard really in terms of how to test, because you can have a 2 access point mesh, you can have a 3, you could have a 4. And so there's many different sorts of configurations. And what we've found out is that there's really no standard testing procedure out there. But one of the things about the Octabox, as I mentioned, is we can isolate, and you can build as many access points as you want into our system. We isolate it, we connect it with cables and our multi-phase attenuator, and we're able to recreate different environments for those access points so the equipment manufacturers can really fine-tune those algorithms for doing beamforming and beam tracking and enable whatever environment. And so as they evolve the software, they can take on more test cases, different scenarios, and the like. So yeah, mesh testing is a big opportunity for Spirent. It's a big growth area for us.
Oh, good. Okay. Well, I'm guessing that in order to perform these tests, you have to get new chips before they're generally available, maybe even to some of the manufacturers. You have pretty close relationships with some of the chip manufacturers.
Absolutely. So we do not build custom Wi-Fi instruments. We rely heavily on the semiconductor industry. And over the years, we forged really great relationships with all of the chip vendors. And that's led to some great products from our team. When we're building our instruments and our test beds, if we find any problems ahead of time, we actually provide that information back to the chip vendors. It's more of a symbiotic. They give us early access. We provide tests that we see when we're building our instruments and doing some initial testing with our lead customers. So it's been a good relationship. And I think the semiconductor manufacturers would tell you that they do really prioritize the test and measurement vendors like Spirent ahead of time because that really accelerates time to revenue for them. Enables them to harden their silicon faster than if they didn't have our participation.
All right. There are a lot of new devices in the home that are getting connected to the internet now. Are there any new IoT devices that you're seeing a particular demand for from the test point of view? Are you seeing a lot of requests to test chipsets for a certain type of device, or are you completely agnostic to the final device that it's going into?
The IoT question, that's a loaded question too, because there are many different types of IoT. And one of the key differences in IoT, there's video and not video. So there's IoT devices like cameras, and they need high bandwidth, Wi-Fi 7. That's a match made in heaven. Pervasive Wi-Fi technology, high throughput, you got better reliability with Wi-Fi 7, with MLO and some of these other standards, or some of these other features like restricted target wake-up time. Those all are better for IoT devices and video. But anything that's also connected to power, Wi-Fi is really a great technology for IoT. And in my house now, I've got air fresheners that are connected to Wi-Fi, believe it or not. And I got a new washer that has Wi-Fi connectivity to it. So in the context of, if there's video, that's an obvious one, I think, for Wi-Fi. There's also where it's just connected to power, just because of the pervasiveness of Wi-Fi. Almost every home has it now. Businesses have it. Any sensor or device that actually has a powered connection could benefit from Wi-Fi, and that's what we're seeing. And then our test as a service business, I'll be honest with you, we're getting a lot of companies that probably aren't used to doing wireless sorts of tests. They're relying on us as a test expert to help them. Those aren't necessarily Wi-Fi 7. Some of those are the more older technologies. But that's one of the benefits of Wi-Fi. Not only is it pervasive and it's everywhere, but I think one of the key points that's about Wi-Fi that makes it so ubiquitous is the fact that it's backward compatible. And so our instruments that we use in our Wi-Fi 7 latest and greatest tester, we can test the down revs of Wi-Fi 6 and Wi-Fi 5. It's all backward compatible. And I think that's one of the key strengths and key pillars of the Wi-Fi ecosystem.
Definitely. So when you say there are new types of companies reaching out to you, are these companies that make the end user devices?
Yes,
that
that's correct.
About? Oh, okay.
Yeah, our biggest business is access point and routers, but we do test endpoints. We have some fairly large customers that do endpoint testing, and then our station testing, as it's known in the Wi-Fi community. But we're seeing a lot more interest from those companies, at least saying, hey, our engineers are seeing this. You've got, the latest and greatest technology. Are you seeing the same thing as well? And those have led to some pretty interesting engagements. And also, we're seeing some differences in chipsets that we hadn't seen before. That's also coming to light. So that's quite interesting.
What types of differences do you mean?
I think interpretations of standards and their implementation. I think there are some semiconductor vendors that are pretty ubiquitous. Some maybe not so much, but they have some specialized feature for a particular application. And then when you connect it to our access point in our test bed and they see an aberrant behavior, that's when it's like, what happened there? And we can help them.
Yeah.
And I can say that through that journey, our stuff has come out looking pretty good.
That's great. Okay, well, we are about out of time. Are there any applications that you want to highlight or anything else about Wi-Fi 7 that you want to be sure we talk about while we're here?
The IoT question is a good one. Some other features that we didn't touch on with Wi-Fi 7 are this restricted wake-up time and some enhancements in terms of OFDMA that I think for the other types of applications, maybe not video, are really important. Restricted target wake-up time means that there's actually a dedicated slice in terms of time and frequency allocated to a particular device. That's never been done before. Even cellular doesn't really have a technology like that. So if you have a device and it's connected to power, has battery powered, and it's critical that it transmits or receives at a particular time, that is a new technology in Wi-Fi that is available to the masses. That's pretty interesting. I mean, I think one of the challenges on the cellular side, I've seen both, is this challenge of latency. And because of the cellular infrastructure, cellular infrastructure is pretty heavy. And to guarantee a particular latency in 5G has always been a challenge. And one of the ways that the Wi-Fi community has addressed that, just because of the nature of the network, the access point is pretty close to the device in most of these applications, that this low latency is actually pretty achievable.
Oh, that's super interesting. I'm glad you brought that up. All right, James Kimery, VP of Product Management at Spirent. Thank you so much for being here on The Signal.
Thank you, Martha.
And that is our show. Don't forget to check the show notes for more resources, and be sure to follow The Signal on Apple Podcasts, Spotify, Amazon Music, or wherever you get your podcasts to get all the latest episodes straight to your device. Of course, you can also find us at the Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse. Thanks very much for listening, and join us next time on The Signal.